Welcome to CEC lectures. Myself Dr. Priti Jagwani. I am from Department of Computer Science, Albert College, University of Delhi. So in this series of computer networks, we have wrapped up our topic of OSI model, and now in this today's lecture we are looking into are there any alternatives available to this OSI model, and if yes, what are they, and then we will be kind of taking one of them into for a greater level of detail. In the past we can say various networking models were used, such as we can say sequenced packet exchange was one model, which was known which was more commonly known as SPX. Internet packet exchange as IPX was the another model, or it could be network basic input output system, which was NetBIOS. So all these were kind of alternatives to OSI model, which were prevalent in the past. But nowadays, today, the main alternative to this OSI ISO model is your TCP IP model. Now, this TCP IP model is having 5 layers. What are those 5 layers? What are those function of 5 layers? We will be looking into them. So, these 5 layers of TCP IP model are physical layer, then data link layer is there, network layer is there, transport layer and application layer. So, unlike your ISO OSI model, which was a model of 7 layers, your TCP IP is believing in only fewer layers. Then these now how is the mapping of these layers is going to take place between TCP IP and OSI. So, when we say the physical layer, the network layer and the application layer, they appears to map directly to the OSI model. This is not quite the case, we can say. Instead, the TCP IP model must accurately maps to the structure and protocol of the internet. So, TCP IP is nowadays kind of we can say more used. OSI model is a theoretical a popular networking model to describe how this communication operates from a holistic perspective, from an educational perspective. But if we talk about practice, which is more commonly is used in practice, is that your TCP IP model. So, if this TCP IP model is also a framework that is used to model the communication in a network. So, basically a collection of network protocols, and organization of these protocols is in the form of different layers, which we have kind of already seen in our we can say in our OSI model. So, OSI model has 7 layers, while TCP IP is look into kind of less number of layers, and but it is more commonly used in today's internet and networking system. Now, if we say what is the role of TCP IP, so one of the main goal is to make sure for any networking system, if we talk about, or for any networking model, one of the main goals is to make sure that the data sent by the sender arrives safely as well as correctly at the receiver's end. And in order to ensure this safety and correctness or accuracy, we can say the data is to be broken down into smaller parts. We can name them parts, we can name those parts as we can say packets, and then that broken data or those packets are to be kind of sent. But these packets will not travel on the similar path. That means they can travel separately if there are multiple paths from sender to receiver, and at the receiving end or when they reach at the destination, that those packets are to be reassembled. And yes, in this whole process we also need to or the model also needs to prevent the errors and make sure that the message is not only complete but the accurate also. Now, looking into the layers of these TCP IP model, the first layer or the topmost layer which is closest to the user is your application layer. This is all your where all your applications are used. It could be an email client, or it could be a file sharing tool where you are using FTP, or it could be a web browser where you are using HTTP. For email clients, SMTP is going to be used. So, this is basically, we can say, this layer acts as a bridge between the software, whatever software you are using, whatever interface you are using, and the lower layers of the network. And the job of the lower layers is to send and receive the data that is being done by the lower layers, but at the top we have a layer which is closest to the layer, and that acts as in bridge, or more technically we can say that acts as an interface between the software and the lower layers. So, here are basically you can say the layers of the main, or we can say the prominent layer of your TCP IP model. So, we have application layer, transport layer, internet layer, data link layer, and then data goes on physically. So, we can, or we may not, we may or we may not say there is a physical layer also. So, from sending host to the receiving host, creation of request is being done by application layer. Then transport layer is going to add some TCP UDP segments onto it for the obtaining the services. Then at internet layer, it is the data is converted in the form of IP datagrams, and at the data link layer it is being converted into frames. And then we can say down the data link layer, if we consider physical layer over here, then this data is kind of transmitted in the form of raw bits. At the receiving host, the data link layer of the receiving host hosts some frames. Then these frames are converted into, or kind of modified into IP datagrams at the internet layer. At the transport layer, they are TCP UDP segments, and at the application layer, it is kind of, we can say, the request which was being created is now being performed. So, in this way the whole kind of communication takes place. Let us try to look all these layers into details. So, the first one, which is application layer, it supports different protocols, like let us say HTTP, as I have told you, if you are using any website using Google Chrome or something of that sort. Then for file transfers, we have FTP and SMTP for email clients, and DNS, which is domain name server, for finding the website addresses. This application layer also manages the things like data formatting, so that the sender and receiver both understand the data. Encryption is also being kind of, we can say, taken place at this layer in order to keep the data safe, and also the session management to keep track of ongoing connections. So, all these functions here, so which is managing the formatting of the data, encryption also, and session management is also the job of this application layer here in this TCP IP model. While if you can recall your OSI model, all these functions were kind of aligned with different layers in OSI. For session, we have session layer over there. For encryption and all that, we have presentation layer, and also to talk to the user, we have application layer. But here in case of TCP IP, this is not the case. Moving on to the next layer, which is the transport layer. Now, transport layer is there in order to ensure that the data is sent reliably and also in the correct order between devices. Then it checks the data which is to be sent, maybe a file, video, or any message, that it arrives safely and also completely, by ensuring the sequence numbers and so on and so forth. This layer, which is the transport layer, is going to use two main protocols here. One is TCP and UDP. These two protocols are there, which they are there for connection oriented services as well as connection less services. So, depending upon which type of communication you need, whether you need a reliable communication or you need a faster communication. So, in case of faster communication, you can go with connection-less services, but if you need more of a reliable communication, you need to go with the connection-oriented services. So, TCP is used when the data must be correct and complete, the thing is when you are loading a web page or downloading a we can say text file or something of that sort. So, it also checks for the errors, resend the missing pieces and keeps everything in order. So, that kind of data delivery here is being ensured by a transport layer if it is using a protocol which is nothing but TCP. On the other hand, if this transport layer is using UDP, which is user datagram protocol, the delivery is faster but not reliable. That means it does not guarantee the delivery for the useful things. It does not guarantee delivery useful for things like live video or maybe online games, where speed matters more than the perfect accuracy. So, depends on whether you need reliability or you need kind of speed. That depends on whether your transport layer is going to use the UDP protocol or the TCP protocol. On the lower side of that transport layer in your TCP IP model, there is a layer which is the internet layer. It is used for finding the best path for the data to travel across different networks, so that it can reach the right place at its destination. So, basically the work is like a traffic controller which helps the data packets move from one network to another until they reach the correct device, and this layer uses the internet protocol to give every device a unique IP address which helps identify that where the data should go. Now, please recall this kind of function was performed by which particular layer if we talk about OSI. So, this was actually the network layer which gives every device a unique IP address, then it also kind of helps in routing. Here that functionality is being kind of performed or being taken over by the internet layer. Here also in TCP IP model, the main job of this layer is the routing. That means deciding which is the best way or which is the best path for the data to travel, and it is not like that all the packets are going to travel on the same path. No, I mean like different packets may take different path depending upon the congestion at that particular time and other factors also, but at the receiving end they all are reassembled in a proper kind of we can say sequence. Also this layer which is the internet layer here, it also takes care of the packet forwarding, that is moving data from one point to another, fragmentation also, which is kind of breaking the large data into smaller parts, and also addressing. So, it is not only the routing, but the fragmentation, then addressing and forwarding are also the issues which are being taken care by your internet layer. On the lower side of the internet layer, we have kind of data link layer. The other name of this is you can say network access layer, which is the bottom layer of the TCP IP model if we are not kind of we can say segregating the physical layer differently. So, if we segregate the physical layer differently here also, then it will be data link layer and the physical layer, or we can combined we can say in a combined manner that we can name them as network access layer also. So, it deals with the actual physical connection between devices on the same local network, and please recall that this was the we can say function of physical layer in your OSI model. So, it deals with actual physical connection between the computers connected by any media. It could be the computers are communicating through Wi-Fi, or it could be through any cable, and these layers also make sure that the data can travel over the hardware such as wires, switches, or it could be in the form of wireless signals. Apart from that, It also handles important tasks like using MAC addresses to identify the device. Now, please recall this was the job of data link layer as far as OSI model is concerned. Apart from that, creation of frames, which is actually a format used to send the data over the physical link here, and then checking for the basic errors during transmission is also the job of this network access layer. Now, please recall our previous lecture, we have seen one complete data flow or the example in which we were trying to send the data, or in which we were trying to look into the whole data flow from sender end to the receiver end. Similarly, here also in TCP IP model we will see that what happens when it happens with the data while sending from one end to another. So, first of all, the application layer, which is on the receiving which is on the sender side, comes into the picture. It prepares the user data using different protocol, depends upon what kind of application you are using, as I have already told. It could be HTTP, it could be FTP or SMTP. Then there comes transport layer that breaks the data into segments and ensures the fast delivery if it is UDP based, or ensures the reliable delivery if it is TCP based. So, depending upon which kind of whichever protocol you are going to use. Moving further in this line, we have internet layer whose job is to add the IP addresses and decides the best route for each packet. Then you can say link layer, or as I have already told you, you can say network access layer, which converts packets into frames and sends them over the physical network. So, this is actually happens, or this kind of data flows goes when we talk about TCP IP model. And here is the we can say what are the different functionalities which are going to be taken care by which particular layer. So, here is a comparison between OSI and TCP IP model in terms of aligning the functionalities. So, whatever functionalities were performed by OSI's application layer, presentation layer and session layer are basically kind of we can say taken care by application layer at in the TCP IP model. The functionalities of transport layer are maintaining functionalities of the transport layer of OSI model are maintained here by the transport layer of TCP IP model. Similarly, the network layer is being maintained here as well. It could be in the kind of different we can say name. But the data link layer and the physical layer, the functionalities of these two layers is being kind of we can say combined and given to the network access layer if we talk about TCP IP model. But if we kind of some literatures give you that there are 5 we can say layers of this TCP IP model, then this instead of this network access layer there are kind of separate data link layer and physical layer. But we have application layer which is performing the task of the 3 layers of OSI model, which are application, presentation and session. We have transport layer as well. Then yes, network layer and network access layer, which is taking the responsibility of the 2 lower layers, which are the data link layer and physical layer. Now, when the data is going from the sender to the receiver end, from sender's end all these layers do their own part, but what actually happens at the receiver's end when the data is being received at the destination, the link layer or the network you can say access layer receives the bits from the network and rebuilds the frames to pass to the next layer. Internet layer, which is in the place of network layer, checks the IP address, removes the IP header and then forwards the data to the transport layer, which is just above this internet layer. This internet layer we can say was named as the network layer in the OSI ISO model. Transport layer, it again reassembles the segments, check for the errors and ensures that the data is complete in each and every manner. And finally, the data is being delivered to the application layer, and by the application layer it is handed over to the correct application. It could be an email or it could be a web page in the web browser. So, here you can see as I have already told you what is the mapping or alignment. So, application layer in case of for the substituting 3 layers, then transport layer, then for network layer we have internet layer here, and for data link layer and physical layer we have network access layer here. So, yes, we can say at at a reasonable level of detail we can say that TCP IP works with 4 layers if not 5. So, now what is happening here? If we look into the comparison of these two models, we can say a TCP IP is more of a practical, more of a kind of real mannered model which is going to be used, and because of the kind of number of layers which are less as compared to OSI model, your TCP IP model is relatively we can say easier to kind of understand. Now, this builds the motivation that why TCP IP is used over this OSI model, because it is as I have told you, it is simpler, it is practical, also it is widely adopted for the real world networking and also for the kind of internet. And we have also seen the diagram which shows the comparison between OSI layers and the TCP layers. Now, again if we say the TCP IP model is kind of used more, or it is more of a kind of preferable model. So, we have reasons. It is in simple in a structure having only 4 layers as compared to the 7, making it easier to implement and also to understand in an easy manner. The design here is actually the protocol driven. Why I am saying this is TCP IP model was designed based on already working protocols, while when the OSI model was designed, it was more of a theoretical framework, and because of this design your OSI model lacks in flexibility and robustness, while your TCP IP adopts well to different hardware, different network structures, which includes error handling, routing and congestion control kind of more efficiently we can say. Then your OSI, your TCP IP is open, free to use and not controlled by any single organization, while your OSI model is completely controlled by ISO, which is an organization. So, it is this free to use nature of this, or this open standard nature of TCP IP model is giving it as a universal, giving it a universal acceptance. And also your OSI model is more of a conceptual model, while if we look into the TCP IP, that is actually used in the real world networking. So, on the basis of all these parameters, which is open standard, conceptual versus actual, then we have simpler structure, a protocol driven design, and because of this flexibility and robustness, your TCP IP is kind of more of a usage. If we look into the other advantages of TCP IP model, then we can say yes, interoperability is one of the advantages, then scalability, because TCP IP is highly scalable, making it suitable for both small networks as well as large networks. So, when we say small networks, it could be a very kind of a small local area network, or it could be a wide area network like internet. So, your internet also operates on this TCP IP model. So, yes, scalability is one kind of big advantage of this TCP IP. Then it is based on open standards, as I have already told you. It ensures, in this way it ensures that different devices and softwares can work together without compatibility issues. Also, this model is more flexible because of its supports to various routing protocols, different data types, and various communication methods. So, it is more adaptable to different networking needs. Also, as far as when we talk about the reliability, reliability is more in case of TCP/IP model, because it includes error checking and retransmission feature, which ensures the reliable data transfer even over longer distances. As far as disadvantages are concerned, security concerns is one of the major disadvantages, because TCP/IP, when designed, it was not designed with security concerns which cropped up on the internet. That thing was not in the mind of the designers. Then there are now so many security protocols available as SSL, TLS, and they have been added on the top of the basic TCP/IP model, and these kind of extra kind of plug-in addition is going to lead to the vulnerabilities. Also, it is inefficient for small networks, that for every very small networks, the overhead and complexity of TCP/IP model is kind of leading to the unnecessary hassles. Data overhead and limited address spaces, although that limited address space is being now taken care with the help of IPv6, but with older IPv versions there were issues with TCP/IP model also. So, in this lecture we looked into the TCP/IP model, and we have also we also try to understand the functionalities of its different layer, and how it kind of we can say mapped in terms of aligned with the OSI model. What are the layers of OSI, which these functionalities of OSI model are being taken care by which of the TCP/IP layers that we have seen, and we understood the concept of the alternative TCP/IP model, which is kind of more practically or more real time being used more practically in the real life applications. So, here is a list of references which is being used for the preparation of lecture. I hope you have enjoyed this one. I will see you in the next. Till then, take care. Goodbye.